This video was produced during March 2020 during the school closure mandated by the COVID-19 pandemic. We recommend that you wash your hands both before and after watching it. Thank you.
M times V, just a little momentum. M times V, just a little momentum. M times V, just a little momentum. M times V. He said, when you're stuck in that chair, your mass is going nowhere. You need some velocity to have a little M times V.
The sportscasters on the NFL Network know about momentum.
Obviously, a very important month in the NFL with regard to playoff momentum.
Everybody talks about momentum, even banks.
We're growing. We're local. We've got momentum. Want some? First Midwest Bank. Bank with momentum.
However, in physics, we define momentum as mass in motion. An object's momentum, symbolized by P, is equal to its mass in kilograms multiplied by its velocity in meters per second. The resulting unit for momentum is the kilogram meter per second. As you can see from the equation, an object's momentum is directly related to both its mass and velocity. Furthermore, momentum is a vector quantity, meaning it has both magnitude and direction. The direction of an object's momentum vector is always the same as the object's velocity vector. Remember, velocities can be positive or negative contingent upon the object's direction. Because that is true, an object may have either a positive or negative momentum based upon its velocity. Finally, because a net force is required to change an object's motion, it follows then that a net force is required to change an object's momentum. Here's the first of two momentum sample problems. What is the momentum of a 2.0 times 10 to the third kilogram truck moving with a velocity of 35 meters per second in an eastward direction? Let's identify our givens first. 2.0 times 10 to the third kilograms, that's a mass. 35 meters per second in an eastward direction, that's a velocity, and it's also a positive velocity because it is in an eastward direction. What's our unknown? What are we looking for? We're looking for momentum. Momentum is a product of an object's mass and velocity, both of which we're given here, so it's simply a matter of substitution to determine the object's momentum. So the momentum of this truck is 7.0 times 10 to the fourth kilogram meters per second. And that would be a positive value because the truck is headed in an eastward direction. Here's the second of our sample problems. The momentum of a car traveling in a straight line at 20 decimal point meters per second is 24,500 kilogram meters per second. What is the car's mass? Our first piece of given information is 20 decimal point meters per second. Nothing else is stated, so we're going to assume that's a positive velocity. The momentum is 24,500 kilogram meters per second, and that's our second piece of given information. What's our unknown? What are we looking for? We're looking for the vehicle's mass. Just like in the first sample problem, we'll begin with the basic equation for momentum, P equals m times v. However, in this problem, we're not looking for momentum, we're looking for the car's mass. We'll begin by substituting what we do have in that expression and then do the rearrangement so that we can solve for the mass. In order to solve for the car's mass, I'll need to isolate the variable m on the right-hand side of the equation. In order to do this, I'll divide the right-hand side by 20 decimal point meters per second. But remember, whatever I do to one side of the equation, I must also do to the other. Once we divide the left side of the equation by 20 decimal point meters per second, you'll notice that the meters per second as units will cancel out, leaving us with the desired unit of kilograms. Our final answer for the mass of the car is 1.2 times 10 to the 3 kilograms. Funding for this video was provided by the makers of Clorox. Clorox, makers of antiseptic wipes for any occasion.